All right, students, take a look here at the next set of notes. We're going to take a look at maybe something that is a review from Algebra 1, relations and functions, and kind of testing whether relations are functions. The first thing that we're going to take a look at here, again, this is just below the last of the notes here, but this is in the next page of the notes packet. We're talking about relations. Relations are just a group of points, right? So we're just taking a look at it. They can be written in different forms. You can see that they can be written in a table, a graph, what we call a mapping diagram. But that's how we can kind of organize those ideas. All right. Whenever I have a relation, one of the questions you can ask is yes or no. The answer is yes or no. Is this relation just a function, right? So a function is a specific type of relation without repeating x's. Now that repeating x's can look a lot of different ways, x values. All right, so this can look a lot of different ways. You can see here's one that's not a function, right? It's not a function because look, see how there are two repeated x values? But this one is a function right here, okay? So that one is a function. The reason it is because if I look at each one of these, there is no repeating, right? So therefore it is. Now you could look at that on a graph or a mapping diagram as well. All right, so the question is, does it matter if x's repeat? Yes, it does, but what about y's? And the answer is no, it doesn't matter if y's repeat. Now, one of these things with these functions is this next idea called a function notation. A function notation is a way to kind of describe some different kinds of functions here. So we have this equation, y equals 3x plus 2, and we could actually just plug x's in for it and things like that. But a function notation is written as f of x, and that's read as this, f of x equals 3x plus 2, right? It's not f times x, but it's called f of x. Now, here's the reason we use function notation. If I look at all of these area formulas down here, and I said, hey, use the area formula, you may not know exactly which one I'm talking about. Okay, well, use the area formula that talks about a rectangle, right? Maybe that's more descriptive. But a different way to do that is just by giving it a name, right? So if I were to ask a question in the class and I wanted one specific person to answer, I wouldn't say students. I would use that student's name. And that's kind of the same thing here, right? So it lets us be more specific for these names, right? More clarity, because we know exactly which one that we're actually talking about here. And so that's why it's hard to tell those apart if we just use the A. But look down here. It says using the functions to evaluate. I have three different functions. I have the f of x, a g of x, and an h of x. And look at each of these letters here. They tell me which one to actually use, right? So f of 5 right here, I could say f of 5 is 4 times 5 minus 6. So f of 5, and again, just following order of operations, is 20 minus 6, or f of 5 equals 14. Now, each of these here, when we're looking at this, can also be written as a point. So this function notation, f of 5 equals 14, can also be written as 5 comma 14. These are equivalent statements right there. The reason for function notation is because I have a lot of different functions, and I just wanted to know which one to actually plug it into. All right? Let's do one more of these here. So kind of just going over to give myself some space. G of 0. And if we're looking at g of 0, we could say it's the absolute value of 0 minus 3. Oops. And g of 0 is the absolute value of negative 3, and g of 0 equals 3. So again, the point would be 0 comma 3. You could write them either way in function notation or as an ordered pair. We could do this again from a table. Notice that every single one of these points is f of x, and so that kind of matches up with what we're looking at here. Now, when we're doing this here, f of 4, we're actually going to look for it. Again, this is the x value, so f of 4 just means f of 4 equals 8. again, we could, excuse me, not 8, my apologies, not sure where I was looking there. Should be f of 4 equals -5, right? That's the y value that goes straight across with it right there. And again, if you wanted to, or were asked to do this, you could write it as an ordered pair as well. We could look at those x values as, for the answer, all right? So when we're looking at this here, note that you can, and just kind of filling this out here, you can have these function notation, and the function notation might be helpful when we're actually looking at this. Thinking about number 4 here for a second. Sorry, thinking still. Let's actually just work it out just to make sure I'm not going to make a mistake. So it's 2 times 4 squared plus 3 times 4, and then plus 5. And so what is that? 2 times 16, or 32, plus 12 plus 5. Again, that was just h of 4. And h of 4 equals 44 plus 15. 44 plus 5, excuse me. 44 plus 5 is 49. Right, we can keep doing this. F of -1 is just 7. F of 0 is 2. Right, so just kind of even checking your answers for that as well. And the last one here is just using the same thing with the graph and going from there. Again, g of 3, that's the x value. So I want to know when is this graph exist. So it'll be g of 3 equals 2. G of -2 is +1. And g of -1 is 0. So use some of the extra resources that I posted there on the daily agenda, and we'll go from there.